Let's take another look at radian measure. A central angle is one whose vertex, here, is at the center of the circle. An arc is a piece of the total perimeter of the circle here. Now, if the arc length here is exactly the same as the radius, that forms an angle of 1 radian exactly. This angle here is 1 radian, and it takes 2 pi radians to do a complete circle. And this circle, if we start here and go in this direction all the way around, this is called positive 360. If we start at this position here and go all the way around in the opposite direction, this angle would be minus 360. Now 2 pi radians gives the entire circle, so what we find here is that 1 radian here is 57.296 degrees roughly. If we were to multiply this by 2 and times pi, we would see that indeed that is 360 degrees is equal to 2 pi radians. If we want to convert degrees to radians, we know there are 2 pi radians for every 360 degrees. So we multiply the degrees times 2 pi per 360 degrees, the degrees go out and we are left with radians. And if we want to convert the other way, if we want to start with a radian measure, and we multiply that by the inverse of this, which is 360 degrees by 2 pi radians, the radians will cancel out and we'll be left with something in degrees. So if we want to convert 47.6 degrees to radians, we put in 47.6 and we would multiply by 2 times pi, and then we would divide by 360. And we would indeed come up with 0.831 radians. Let's take a look at going from radians here to degrees. We start with 1.8473, and we're going to multiply that by 360, and we're going to divide by 2, and we're going to divide by pi. And in this case, we end up with 105.84 degrees. That's equivalent to 1.8473 radians. Now we can also work on how many revolutions this is. For instance, what is 47.6 degrees in terms of revolutions? Well, one complete revolution generates 360 degrees, so again we can cancel out the degrees. So we put 47.6 divided by 360, and we find that that is 0.132 revolutions here. Same thing with radians here. We multiply 1 revolution per 2 pi radians times the number of radians. So that would be 1.8473 divided by 2 divided by pi. We would have 0.294 revolutions here. Let's see how we'd go about converting 1.837520 radians to degrees, minutes, and seconds. First thing we have to do is convert it to degrees. So let's put in our number, 1.837520. And what we have to do is multiply it by 360 and divide it by 2 and divide it by pi to get this in degrees, which is 105.2821 roughly here. Now if you remember, our degrees are going to be 105. So let's subtract the 105, and we're left with this number here. Now to convert this fractional part of degrees to minutes, there's 60 minutes per each degree. So we're going to multiply this by 60, and the degrees cancel out, and we'll be left with a fraction. So let's do that. Let's multiply this by 60, and we get 16 point something. So 16 will be our minutes. So you can see our 16 minutes here. So let's subtract 16 from this. And again, we have 60 seconds for every minute times the number of minutes. So the minutes will go out and we'll be left with seconds. So let's multiply this times 60. And we're going to get 55.7, which is roughly 56. So our answer here would be 105 degrees, 60 minutes, and 56 seconds. It is possible to have radian measure in terms of pi. For instance, 360 degrees, which is one complete revolution, is equal to 2 pi radians. Half of this is 180 degrees is equal to pi radians. Half of this is 90 degrees is pi by 2 radians. Half of 90 would be 45 is pi by 4 radians. And 1/3 of this, 45, would be 15 degrees is going to be pi by 12 radians. Let's take a look at example 4. It says express 135 degrees in radian measure in terms of pi. Now normally we'd multiply 135 degrees times 2 pi radians over 360 degrees, but that's the same thing as multiplying by pi radians over 180 degrees. So when we do this, we get 135 pi over 180 radians. And when we work that out, we get that that's 0.75 or 75 over 100 or 3 over 4 pi radians. Now there's a big difference here between pi and pi radians. Pi itself is 3.141592654, but pi radians is 180 degrees. So we have to be careful with that to make sure that pi radians is 180 degrees, but pi by itself is only 3.141592654. Let's take a look at example 5. It says convert 7 pi by 9 radians to degrees. So there's our 7 pi by 9 radians times their conversion factor of 180 degrees per pi radians. I think you can see the pi radians will cancel out, and we're going to be left with 7 9ths of 180. 7 times 180 divided by 9. And we get 140 degrees. Now example 6 says use your calculator to verify that these are correct. Now make sure that we're in radians, so because if you have degrees, this will be in degrees. Switch to radians, it says these things here are now considered radians. So let's put in 2.83, and let's look at the sign of that, and we get 0.3066 as it shows here. Let's take a look at 1.52, and the cos of that is 0.0508 as you can see here. And finally, let's take a look at 0.463 and take the tan of that, and we get 0.4992. So these all do validate. Let's take a look at example 7. It says find the secant of 0.733 radians. So we have to make sure our calculator is set to radians. We're going to put in 0.733. Now if you remember, secant and cosine are opposites. So let's take a look at the cosine of that and do the reciprocal. And we get our answer here is 1.346, rounded to 3 decimal places it asked for here. Now it says example 8, use your calculator to verify the following to 4 decimal places. So let's clear. And cosecant of 1.33, again we're in rad, so it's 1.33. Cosecant and sine, so sine 1 over, and we're going to get 1.0297, which is what we have here. Let's clear and do the next one. Cotangent of 1.22, 1.22. Let's take the tan, let's take the inverse, and we get 0.3659 here. Let's do the last one. Secant of 0.726, 0.726. Secant is opposite of cosine, so let's do the cosine and do 1 over, and we get 1.3372. And that means we validated all of these as being correct to 4 decimal places. Example 9 asks us to use your calculator to verify the following in radians to 4 decimal places. Arc sine means inverse sine, so make sure we're in radians, and we're going to put in 0.2373, and we're going to do the inverse sine, and we get 0.2396, which is what it's got here. Let's take a look at the next one. Inverse cos of 0.5152, 0.5152. Inverse cos is 1.0296. Let's take a look at the arctangent of this, 3.246, when rounded to our 4 decimal places that it mentions here. Let's take a look at this question here. It says if theta is equal to the cotangent of 2.745, find theta in radians. Now if this is the cotangent, the tangent is going to be the reciprocal of this. So let's put in 2.745 745, and let's do the reciprocal of that and do the tangent of that, and we're going to get our answer of 0.3494. Let's look at example 11. It says find the cos of 5 pi by 12 to 4 significant digits. So let's multiply 5 times pi and divide that by 12, and then we're going to take the cosine of that, and we get 0.2588, as we can see here. Example 12 is a little more interesting. It says find this to 4 significant digits. So let's do 2 times pi equals divided by 5 equals cos of, and then times 5 equals. Now that's the first part here, and we're going to do a memory plus on that. Then we're going to clear, and then we're going to say 3 times pi equals divided by 7 equals, sine of that is this, squared times 4 equals memory plus memory recall, and we get that it's 5.347 as is shown here.